Okay, lastly, question number 5. So question number 5 is a two-sided or two-sample test. And so a physician hypothesizes that the average weight of newborns born to smoking mothers is less than the average weight of newborns born to non-smoking mothers. Okay, so actually I'm going to have to edit this and let you guys know. Assume that the population standard deviations are not the same, or not equal. Each group. Okay, so we're going to do the t-test, right? T-test, why? Because their sample size is small, and then we're going to assume that the population standard deviations are not equal in each group. So what chapter is this from? This is 8.2. So we'll go to where the population, two sample tests for difference between means, the variance they're equal, the variance they're not equal. See, so this is the test that we'll be using. Okay. So we're using this standard error estimate, and then our test statistic is still going to look like this. Okay. So I'm going to type right here, problem 4, or problem 5. Okay. Your Excel file doesn't need to look exactly like this, but it should look neat. Like I should have nice labels over top of each problem and everything, so I can tell what's going on when I go in to read your Excel file. Okay, so they're hypothesizing that the weight of newborns born to smoking mothers is less. So it's less in the smoking. So the average for the smoking is less than the average for the non-smoking mothers. Okay, so when you're writing your null and alternative hypothesis, you know, that's where you get that from. So the alternative is going to be the claim, right, that it's less. All right. So go ahead and we'll write X bar. We need two groups, so I'm gonna say you know, NS is non-smoking. Okay. And so this is the sample mean for the non-smoking. I'm just going to highlight that cell up there for sample mean for non-smoking. And then X bar for smoking is going to be the sample mean for the smoking group. Then we have S for NS. Okay. And then S for the smoking group, the standard deviation for the smoking group. Say equals, and I'm just going to highlight this cell. Okay, and then, so now I'm ready to go ahead and calculate the standard error. So the standard error was SQRT. Actually, one more thing I should add, I guess, is a sample size for both of these groups. So N for the non-smoking group is, you know, this is 16 up here. And then N for the smoking group is, so I say equals, and I say the 16 up here. Okay. So square root of S squared, S1 squared divided by the sample size for the first group plus the standard deviation for the second group squared divided by the sample size for the second group and the square root parentheses. Press enter. So there's the standard error. And then our test statistic is going to be equal to the sample mean for the first group, okay, I'll say non-smoking, minus the sample mean for the smoking group, okay, divided by the standard error. Alright, so this, the way I've set it up, where I have non-smoking minus smoking, right, if this difference, right, if the alternative is true, that those born to smoking mothers is less, then this difference should be positive, right? So that would be a right-sided test, okay? Now, if you set it up, you know, smoking minus non-smoking, then it's a left-sided test. So it depends on how you set up your null and alternative hypothesis, and then how you do your test statistic. So right now it's a right-sided test. So when I do my p-value, okay, I'm going to have, before I do my p-value, actually, I need to do my degrees of freedom. Right? So what's my degrees of freedom? So if you forget, we go to the slides. It's the smaller of n1 minus 1 or n2 minus 1. Okay, in our case, both the sample sizes are the same, so it's going to be at 16 minus 1. It's going to be 15. Okay, so when I'm doing the p-value, t.dist, I'm going to highlight that test statistic value, and then I'm going to say the degrees of freedom. I'm going to say true. Now, if it's a right-sided test, I'm going to need that 1 minus. Okay, so there's my p-value. It's really small, so it's 0.00017. Okay, so now you should be able to say whether or not you reject or fail to reject the null hypothesis, and then say there's enough evidence to, there's enough evidence to support that smoking, that the birth weight of the birth weight of newborns born to smoking mothers is less than the average birth weight of newborns born to non-smoking mothers, or that there's not enough evidence to suggest that claim.